Now that we have the height of every node, we have to check to see if our tree is unbalanced. How do we do that? Very easy. After we append a new node to this root node, it is possible that this root node or one of its parents become unbalanced. So after we set the height, we have to compare the height of the left and right subtrees. We want to make sure that the difference is less than or equal to 1. So here we're going to introduce a new concept called balance factor, and that is equal to height of the left minus height of the right subtrees. So if the height of the left subtree is 5 and the height of the right subtree is 4, the balance factor is 1, we're good. The difference is only 1. However, if the height of the right subtree is 3, now the balance factor is 2. That means our tree is unbalanced. In this case, our tree is left heavy because the difference is greater than 1. So if balance factor is greater than 1, that means our tree is left heavy and we should perform a right rotation. On the other side, if the height of the left tree is smaller than the height of the right tree, our tree might be right heavy. For example, if the height of the left subtree is 3, but the height of the right subtree is 4, the difference is -1, we're still good. But if the height of the right subtree is 5, the balance factor is going to be -2, and that means our tree is right heavy. So if balance factor is less than -1, that means our tree is right heavy. So for this exercise, I want you to calculate the balance factor and see if it falls within this range. If it's greater than 1, simply print which node is left heavy. And if the balance factor is less than -1, print which node is right heavy. For now, don't worry about the rotations. We're going to look at them later in this section. So go ahead and spend 5 minutes on this, then come back, see my solution.